Hi class. So I realize we didn't go over this on Friday, right? The deal is that I want you to spend some additional time, and since we have the time with me not being in the classroom today, thought this would be a good time that we could sort of look at this piece by piece and make sure we're all understanding. So hopefully, especially since you had the extended time, we all have this completed, at least to the best of our ability. Okay, I'm going to go through and you can fix things if you need to fix things, but just make sure you're sort of understanding and filling in those pieces you weren't sure of. So if we look at number 1, polar bears are listed as a threatened species. In 2005, there were about 25,000 polar bears in the world. The number of polar bears declines by 1,000 each year. So we want to write an equation that models the number of polar bears for each year after 2005. Okay, so we're going into this like y equals mx plus b format, but let's just start off with the idea, right? We have 25,000 polar bears, and each year it is declining. So, right, if it's declining, it's going down, it's getting smaller. So we want to subtract 1,000, and since it's happening each year, right, if it's happening per item, then we're going to give it the variable. Okay, this is what we want y to equal. So y is going to equal 25,000 minus 1,000x. Now, if we rewrite that into slope-intercept form, we then have y equals negative 1,000x plus 25,000. Okay, so it then says, what does the slope represent? So slope is our number in front of x. So our slope is our 1,000, or negative 1,000, I should say. Okay, and remember, slope is always representing our y label per our x label, our change in y per our change in x. So we sort of need to know what our x and our y are representing, right? So we have the population of polar bears, and we have years. So the 1,000 is happening per year, so our x is going to be our years, and our y is going to be our population of bears. How many bears we have? So if we want our y per our x, it's going to be our population per year. So it's our decrease in bears, right? We'll be decreasing 1,000 polar bears in our population per year. Our y-intercept is our b, which in this case is our 25,000. Right, and we said our y-intercept is always our starting point. So in this situation, our 25,000, which is our y-intercept, is going to be our starting population. Now, obviously, it's all relative to the story problem. So our starting population, we don't mean the first amount of polar bears that ever existed on the planet, right? But our starting population from when this data was being collected. So it's our starting population when we started collecting data in 2005. Okay, and then our last one, what does the x-intercept represent? Right, we said our x-intercept would be where our x-intercept, is always an x number, comma, a y value of 0. So our y is our population. So when our population is going to be 0, it's our sort of our ending value. Okay, so our x-intercept is going to be when there's no more polar bears. Now, this one doesn't ask us to calculate it or graph it, so we don't know what that is, but we could figure out what that value is. Remember, we said by plugging in 0 for y and then solving it to get an answer. Okay, so let's take a look at number 2. Suppose you are doing a 5,000 piece puzzle. You have already placed 175 pieces. Every minute, you place 10 more pieces. Okay, so we have a puzzle with a total of 5,000 pieces, and we are putting more pieces in at a rate of 10 more pieces. Every minute we're putting in 10 more pieces. Okay, so if we look at this equation, we want to talk about the number of pieces that we already have in place. Okay, we already have 175 pieces in place, and we're going to add to that 10 more more pieces per each minute. So since it's happening per something, it gets a variable. The key piece here is that 5,000 isn't something we need to write in our equation. It's not going to tell us how many pieces we have placed. This is just when we don't have any more pieces to place, right? When we've reached 5,000, the puzzle is done. We will be done with our reasonable domain and range. Okay, so for right now, all we need is y equals 175 plus 10x. Okay, it's then asking us to graph this. So remember, our x is going to be our time. In this case, it's minutes. Our y is going to be our number of puzzle pieces. Now, we're not going to want to count by ones. We'll run out of space, so we need to count by something more reasonable for our puzzle pieces. So I'm going to start here at, like, I don't know, 170, maybe. Okay, 170, and then maybe I'll count by tens by each big hash mark. So in between is by 5, so 170, 180, 190, 200, 210. I don't know, you could keep labeling. Though minutes I'll be fine down here if I just do 1, 2, 3, 4, 5, 6, 7, 8, whatever, how many minutes have passed. Okay, so if I want to graph this, if I rewrite this into really truly slope-intercept form, right, I'll have a 10x plus 175. So I want to start on my y-axis at 175, so right in between 170 and 180. And I want to go up 10 over 1. So up 10, right, this is up 5, up 10 over 1. Up 5, up 10 over 1. And here's what my graph will look like. Okay. After 50 more minutes, how many pieces will you have placed? So 50 minutes is an x value. Time is an x value. So this is asking when x equals 50, how many pieces will we have placed? So we can plug 50 in for x. Okay, so this will give us 500 plus 175. Okay, so after 50 minutes, we will have placed 675 puzzle pieces. Okay, so let's look at our third one here on the back, our last one. Suppose you have a $5 off coupon at a fabric store. You buy fabric that costs $7.50 per yard. Write an equation that models the total amount of money. So it's telling us that money is y. So we know we're going to want money over here. Okay. Money you pay if you buy X yards of fabric. So it's telling us that X is going to be our number of yards. So we know we want yards down here. Okay, so we're going to write an equation. So we are going to spend $7.50 per yard, right? When it's happening per item, it gets a variable. Okay, but once we have that total, we're also going to have a $5 coupon, but this is money that's off. So when it's money that's coming off, we're subtracting that. So we have y equals 750x minus 5. Now, this gets a little bit tricky because if we want to graph this, right, the only thing that's reasonable is what we have in quadrant 1. Okay, and labeling this, okay, we spend $1, $2, $3, $4, 5, 6, 7, 8. These are amounts of monies we can spend, right? And we can purchase 1 yard, 2 yard, 3 yards, 4 yards, 5 yards, 6 yards, whatever, right? We can buy any amount of yards. The problem is that our y-intercept is actually off of the reasonable domain, which should make sense for us, right? Because it doesn't make sense that you're going to go into your fabric store. You're not going to buy nothing and just hand them a coupon and then give you $5. So while it's not in our reasonable domain and range, it is helpful to have that information to graph it. So we'll kind of have to fill in a little bit down here to find that piece. So I'm going to go down here 5 and just keep in mind that it's not reasonable, but I'm using it to help me figure out the rest of the graph. So I'm going to start at -5. Okay, now I need to go up $7.50 over 1. So I'm going up 1, 2, 3, 4, 5, 6, 7, and then 50 more cents, right? So right in between there, and then over 1. Okay, and now I need to go up another $7. So sort of every 2 squares is $1. So $1, $2, $3, 4, 5, 6, 7, and then 50 cents. Oops, and then I'm gonna go over 1. Sorry, I made that dot a little bit too dark there, but okay, so these 3 dots are the ones that are giving us the line that we need. Right, this part isn't important. It's not useful, but it is only useful in helping us get the rest of the graph. Okay, so make sure you have that completed. Okay, you can double check with a neighbor if you need to really quickly, but then make sure your name is on that and then pass that forward because I am gonna collect this and get this in the grade book. I will take care of the grading portion. You just make sure your first and last name are on it and then pass it forward.